This video is video 8.3, and this video is based on calculating the instantaneous rate. As you should know, the rate of a chemical reaction changes over time. It is usually fastest at the start of an experiment and becomes slower as the experiment proceeds. This is due to the reactants being used up and their concentration dropping, which means that the remaining reactants are not colliding as often. There are two ways to measure the rate of a chemical reaction: the average rate and the instantaneous rate. Video 8.1 went through how to calculate the average rate of a chemical reaction. We've highlighted the instantaneous rate as a key term in this book. The instantaneous rate is the rate of a chemical reaction at a particular time during the experiment. There are many reasons why someone would want to calculate the instantaneous rate. For example, some reactions may proceed at dangerously high rates, leading to potential hazards such as explosions or runaway reactions. Calculating the instantaneous rate helps in identifying and mitigating these risks by implementing appropriate safety measures. Knowledge of instantaneous rate allows chemists to optimize reaction conditions to achieve desired outcomes. For example, adjusting parameters such as temperature, pressure, and concentration can alter the rate of reaction, which is essential for maximizing yield and minimizing unwanted byproducts. In industrial settings, monitoring the rate of reaction, particularly the instantaneous rate of reaction, ensures consistency and quality control of products. Any deviation from the expected rate may indicate issues with the reaction process or the quality of the reactant. In this video, we're going to calculate the instantaneous rate of a particular experiment. The data collected in the experiment in which we're going to calculate the instantaneous rate can be seen on the table on the left-hand side of the screen. In the centre of the screen are the 5 steps needed to calculate the instantaneous rate. The first step is drawing a graph of your results. Having watched video 8.2, you should be confident at graphing results from experiments. Step 2 is to decide on a time during the experiment to investigate the instantaneous rate. When answering questions in this book, you will not need to decide on a time during the experiment. It will always ask you to calculate the instantaneous rate at a particular time. Step 3 is to draw a tangent to the curve at the given time. In mathematics, a tangent is a straight line that touches a curve at a single point without crossing through it. At the point of contact, the tangent line has the same slope as the curve. This means that the tangent line represents the instantaneous rate of change of the curve at that specific point. Therefore, in a graph representing, let's say, the concentration of a reactant in a chemical reaction over time, the tangent to the curve at a particular time represents the instantaneous rate of reaction at that time. Therefore, to find the instantaneous rate, in step 5, you need to find the slope of the tangent using 2 points and the slope formula, which is in the formula and tables booklet, but you can see in the centre of the screen here. Calculating the instantaneous rate is best explained by going through an example. If you can remember from the previous slide, the first step in calculating the instantaneous rate is drawing a graph of your results. The results obtained in this experiment are the same results used in video link 8.2. Therefore, if you watch video link 8.2, you will learn how to graph the results of this particular data set. Step 2 is to decide on a time during the experiment to investigate the instantaneous rate. In this particular experiment, we're going to calculate the instantaneous rate at 60 seconds. Now that we've decided to find the instantaneous rate at 60 seconds, step 3 says to draw a tangent to the curve at the particular time. Therefore, in this particular example, we go to 60 seconds and we're going to draw a tangent at 60 seconds. Remember, a tangent is a straight line that touches a curve at a single point without crossing through it. Therefore, when drawing the tangent, it's important that you use a ruler. All I've done here is place the ruler directly on the point in the graph at 60 seconds. I've then drawn a line that only passes through the graph at that particular point and doesn't hit the graph at any other point. Step 4 in calculating the instantaneous rate is choosing 2 points on the tangent. When choosing the 2 points, it's best to choose a point that you can read easily from the graph. So for example, I'm going to choose this point here, and the reason why I'm choosing that point is when we write down the coordinates of that point, we can see that the x value is 35 and the y value is 8. Similarly, we need another point, and it's best to include a point that is easily read from the graph. I'm going to choose this point here, and that particular point is going to be 75 and 11. The final thing that we need to do in this particular example is use the slope formula to calculate the slope of that line. The slope formula can be found in the Formula and Tables booklet, but I also have it at the bottom of the screen on the left-hand side. What I need to do when using the slope formula is label my points x1, y1 and x2, y2. In this example, I'm going to label 35, 8 as my x1 and y1, and I'm going to label 75, 11 as my x2 and y2. All I have to do then is fill in the formula. So here, m is going to be equal to y2, which is 11, minus y1, which is 8, over x2, which is 75, minus x1, which is 35. Simplifying that down, we have 11 minus 8, which will give us 3, and we have 75 minus 35, which will give us 40. If you'd like, you can then go to your calculator to break down that fraction a little bit more if required. However, in this example, it's not going to break down any further. However, we can write it as a decimal, and as a decimal, it can be rewritten as 0.075. What does 0.075 mean in terms of the rate of the chemical reaction? Well, it means that 0.075 milliliters of oxygen gas were being produced at that particular time every second. It's important that when you are calculating the instantaneous rate that you always include your units. So ensure that you have milliliters per second included in your answer. It won't always be milliliters per second. However, you can always find out what the units are going to be by looking at the data you have graphed. You will find the units on the x and the y axis. From watching this video, you should be able to calculate the instantaneous rate at a given time for any particular chemical reaction. In particular, you should be able to use what you have learned in this video when completing the optional student handout that accompanies activity 8.1, where you're asked to calculate the average and instantaneous rate of a chemical reaction. In particular, that chemical reaction is the breakdown of hydrogen peroxide using manganese dioxide as a catalyst into oxygen and water.